Alright, in this tutorial I am going to go through how to create like publication quality tables for your results or for your summary statistics in R. So here's where we would start. I've made a little note to myself here on line 7. You can see there's another file, econmajors.r, that I run, and this is what creates my data frames called employed and salary. So now I've got these already stored here as data frames, and so I can use them in a different script file, which I'm going to call a stargazer. I could call it tables or results or something. And this is where we are going to create our tables of our results. Okay. So this needs a package called stargazer, which you may not have installed yet. So we need to install packages stargazer. Once you do that, you never need to run that line again. So I'll typically erase it. But every time I open R, I will need to load in both the tidyverse. We can use pipes and stargazer. Okay. Now, here's how stargazer works. So let me just run a regression first. So if we want to know what is the relationship between majoring in economics and salary, this is INC, wage, income from wage. Okay, and so it says, non-econ college graduates average $95,000 in salary, and econ graduates, as being an econ major degree holder, associated with an additional $33,000. Okay. Now, stargazer is going to allow us to take these numbers and the p-values and t-statistics, which we can't even see yet, and put them in a table. But we are always going to need to save it as something. Okay, which we know how to do anyways. I'm going to call it results 1 because I'm going to use a couple different models, right? One with controls and maybe one additional model with a square term or an interaction or something like that. So, all right, now we've got the results saved over here. When you open it up, it's a bunch of nonsense in here, but that's okay. Okay, now here's how stargazer works. So the function is called stargazer, and just note that for any of these functions, if you really want to get into the details here on how this works, you can find all kinds of resources online. Just if you find rdocumentation.org, it will show you, okay, here are all the arguments you can use inside of the stargazer function to tell it to do what you want it to do. I'm going to show you the ones I think are most useful and helpful for us, but there's all kinds of things you can do with these functions. Okay, so it starts by just saying which results do you want to gaze at, I guess, right? So if we run that, this gives a bunch of LaTeX code, which I know how to use, but we may or may not. So we might actually want HTML. This will work the best for Word documents. And I'm going to show you how that works in a second. So if we do HTML and I run it, now I get HTML code for a table. I'll do one more step, which is to put a comma here. And what I typically do when I use these functions, there's a lot of arguments that are going to go in here. Arguments mean like there are things we're going to feed it to tell it what to do. Okay, there are a lot of them, and they're all separated by commas. Usually click enter after each comma just to keep my code going downwards. Otherwise, it's going to go off to the right and we're going to not see it. So the next one I want to put in is that I want to save. I don't want R to just like paste this HTML code in the console down here. I want to save it, so I want to output it to something. Let's just call this results.html. Okay, so now I run it, and it doesn't. I mean, it does. It still shows the HTML code down here. However, it's going to save my table into the folder where my project is located. Okay, into that project folder. So here's my college majors folder. It's got a bunch of figures and script files, but it results.html. There it is. So now, if we double-click this one, it'll open in your browser, and we get a pretty nice looking table here. It's got our slope coefficient on econ, and it's got our intercept term, which it calls constant. observations, R squared, and some of the other stuff that we don't especially know how to use or won't. Okay, pretty cool. And this works well because what we can do is just copy, paste this right into Word. Oh boy. Control A, Control C. There we go. Yeah, so Control A will select all of it and then paste it into Word, and then it will look pretty good. So this is how you will put your tables into your paper. Easy enough. You don't need to copy and paste at 33,000. Copy and paste the standard errors. Make sure you get the stars right on the p-values. We don't need to do that. A few lines of code will do it for us. Okay. Now, a lot of research is about communicating what you found, right? So what you need to do is make your tables and figures later on look professional, clean, and be able to convey exactly what you mean. So one thing I want to do here to begin with is we don't even know what adjusted R squared, residual standard errors, or F statistics are. We don't really need them. They're not really crucial to our operation. So I'm going to put in a new argument, which is called keepStat. KeepStat says the statistics that are at the bottom of the table down here, I'm going to tell you which ones to keep. Okay, so what we could do, for example, is just put n, which means keep the number of observations. And now if I just refresh my tab for this file, you can see there's only observations here now. Okay, nice. But maybe I want R squared. I think you should keep your R squared. And if you want, so like whenever, you might have noticed this in code before, whenever you want to feed multiple arguments to one of these, so like keepStat is an argument, but if you want to feed a list, you really want a list of things, right? Then C is the command that will help you do that. You need to close the parentheses. C says, okay, I'm going to give you multiple things inside of these parentheses. I want the n and I want the r squared. Okay. So if I run that, r squared, there we go. And I suggest you build your tables like this, kind of piece by piece. Start with the basic level and just put in your results, HTML, and then your save it, output it to something and open it and take a look and see what it looks like. And then keep going from there, rather than, by the time I get done here, we're going to have another 10 lines here, maybe in our table or in this function. Don't type it all out and then press run. You might get an error and not know where it is. Just go piece by piece. So maybe I look at my table now and I'm like, okay, that's pretty good, except it's kind of weird in some ways because econ doesn't really, it's actually a decent variable name for my paper, but yours might not be. Yours might be like, I don't know, complete nonsense. It doesn't tell the reader what this variable is, what it means. So maybe I want to change the label on it, or one thing I actually want to do first is, as a default, this function uses cutoffs for the p-values. So stars indicate where the p-value is at. And you can see 1 star is for a p-value below 0.1. So it's kind of generous. It's saying if you get a p-value of 0.9, you get a star. But maybe we don't want that. So in economics, we typically don't use statistical significance at the level of 0.1. It's got to be 0.5 or 0.05 or lower. So I can tell it, okay, make the star cutoffs 0.05 and then do 0.01 and then do 0.001, a tenth of a percent. And then I'm going to run it and make sure it works. So it should update in the notes and say, okay, 1 star is for 5% significance level, 2 stars 1%, and then 3 stars is 0.1%. Good. Okay, so this is more common in economics as the cutoffs for the stars. Next. I'm getting 3 digits here, so this says that non-economics college graduates earn on average $95,000.75, 0.0 cents, or it could say 0.3, 0.4, just depends. I got lucky and got a 0. We don't need to show tenths of cents, so all I have to do here is do digits equals to 2, and then it will remove that last digit and just show the dollars and the cents. And so with your paper, you will just use your best judgment, like how many decimals should we be showing here? If your y variable is a dollar amount, 2 decimals make sense, right? Dollars show all the cents. If your dependent variable is a dummy, ones and zeros, like is this person in the labor force or unemployed, you might show 3 digits, so that if it's 0.032, you can say that's 3.2 percentage points, so you might show 3, but use your best judgment. There's no reason to show like ever really 6 decimal points. Think about the economic meaning of that 6 decimal point. Whatever your y variable is, it almost surely means nothing, so we don't need to see that far. Okay. Again, we're trying to convey information to our reader. We're trying not to lose them. We're trying to make sure that they are getting useful information. Okay. All right, next we can put a title here. And then, so title is just regression results. That's fine. Cool. Now before I do any other changes in here, like we might want to like ink wage. This is an example of a variable name that's weird. Nobody knows what this necessarily means in my data or in my when they read my paper. So I would want to change that, and I would want to change econ, make this look a little nicer. But before I do that, I want to show you how we can add additional models in here, right? Because there's no controls here. There's no controls. And that's fine. I do want you in your table to have the first column be a no controls model, because what this will kind of do is it'll just show us, okay, just raw correlations. What is the correlation between x and y with no controls? Or you could think of this as, the layperson, wandering around the world, and our brains are good at coming up with correlations. What will they observe? Well, they will observe econ graduates make a lot more than the non-graduates, right? So that's what they will observe. But we know that we would want to have some controls. So, like for example, maybe I want to control for race, okay? But I want to leave this results 1 alone, because this should always appear in my table as a model that I want. So I'm going to call results 2 and add in my controls. And this is where you could add in all of them, everything you want. I'm just going to do 1 to make our life a little bit easier here, but you can go crazy with it here. Right, all of those controls that you decided were necessary, put them here. So I'm going to run this one. So now my results are controlling for the race of the person, and I can come back to this first line of stargazer and say, okay, also show results 2, and let's see what it does. Okay, so all it's going to do now is add a second column and show all of the slope coefficients on every term in my model. Okay, so if we look at column 1, then nothing actually will change. It will just leave blanks on the variables that are not in model 1 or results 1. Okay, which is good. All right. Now, suppose I also wanted, let's just do age. Let me add in a second. Control. Okay. So maybe I wanted age. Okay, there we go. Now I've got age. But again, think about your reader, okay? Your reader wants to know what is the correlation between majoring in economics and your earnings, maybe with some controls. So typically we only want to include the coefficients that are of direct interest, right? And with enough control variables, this gets quite out of hand, all of this information. So, and a lot of it's not of direct interest to us, right? So factor race 6. I think this might be 4. 4 is the race is Asian American, I believe. So this coefficient says, well, on average, Asian Americans make, holding constant econ and age, make $25,000 more than white college graduates. That was the omitted category. That's really not of direct interest to us, so maybe we don't really want to show it. So what I would recommend is coming in here and saying, okay, leave out all of the variables I don't want. So I can put race here, right? Even if you do factor race up here, if you just put race in the omit, it will leave this out of your table. So thankfully you don't need to type all of those races, so that's good. But no, nothing will change. Like this coefficient still is 31,911. That's what it was before I typed omit. Omit says just don't show it in the table. Like it's in the results, it's in the model, but don't show it in the table. Let us focus on what's important. Okay. But you might notice there's a lot that's not important. This 52,000, this is the predicted salary of a college graduate who is age 0, because age is in our x variables. Doesn't make any sense. So in most cases, we also won't really want to show the constant term. And if you're catching on to how this works, I can't just necessarily put a comma and put constant there. If you remember, if I want to feed it a list of things, then I need to list them out like this. And I don't know, let's see, I'm going to run a little experiment. If constant is lowercase, what happens? Nope, it is case sensitive, so constant with a capital C. We don't need to see that. And we don't really need to see age either. Although I could. Ultimately, it's going to be up to you. You can show a few control variable estimates if you want, especially if they're interesting. It's okay. Just make your table manageable. We don't want to overwhelm the reader necessarily. But if you want to keep a few, that's fine. So I could keep age, and that would be just fine. All right. Now, I want to do one more model before we start to clean up some of the other visuals. So your table might end up looking like this. Column 1, no controls. Column 2 has controls. Okay. And then column 3, you might have an additional model that you want to put a square term or an interaction. And let's say that what I want to do is put an interaction term. So here, I've got econ, factor, race, age, and then I also want to do an interaction with female and econ together. I want to see if the value of an econ degree is different for males and females. So model 3, income is not found because it's called inc wage. Good. Let's add that in. Results 3. Don't forget your commas. That little red X there is a warning sign. It's like a check engine light. We got a problem, right? They expect to see a comma. Yeah, so do I. There it is. Okay. Now, it puts female in here now, but this shouldn't be inc wage, should it? This should be econ. Because we want to interact econ with female. There we go. Now female and this interaction term are now in here, and that's because they're not in my omit, right? Omit says leave these things out. I haven't listed them in here, which is good. I don't want to omit them anyways. If you're using an interaction term in your model, then you should always include the other dummy variable that's being interacted. So if it has econ times female, then they should both go in here. Okay, so you should show them both. All right. Great. So this could be what my table looks like in my paper. Although I could also, let's do one more step here. Okay. Because your additional model might actually not be a interaction. It might be, actually I want to do a different dependent variable. So if I want to do, what is the odds of being employed, econ, and let's make it this exact same model, interaction with female. So I have to use actually an entirely different data set because salary is conditional on having a salary. Some unemployed people don't have a salary, so they're not in this data, but that's fine. Results 4 is what is the effect of all of these things, or how do they correlate with being employed? What's that results 4? Cool. Now what stargazer will do here is it'll differentiate now. Okay, well this column is with employed as the dependent variable. The first 3 are using ink wage, which is salary. Okay, and this observations row will let the reader know, hey, look, this column 4, this model is estimated with different data. There's actually another 300,000 people in here, which makes sense, because even the unemployed or not in the labor force people are in this sample. Okay. So then I only have one step left here, which is to kind of clean this up, because we should have capital letters on our variable names, and they shouldn't say ink wage, this should say salary. This should be a capitalized employed, and this could be a little cleaner looking too. Let's make this look a little nicer. And I will always suggest that this is the last thing you do. Okay, when you code these tables, the last thing you do is variable names, and I'm going to show you why that is. So let's start with the dependent variables. These ones, I want this to say salary, and I want this to say employed with a capital E. So dependent variable labels. You can kind of see when as you go here that the function will kind of guess where you're going with this, right? And we want dependent variable labels. I don't like spaces. All right. Now we have 2 of them, and it should just go in order. Okay, so if you mess this up, R is not going to know. If you do employed and salary, there's nothing in the minions in the gears of R that will fix that. It will say employed and salary, so you need to be careful and make sure that as you go here, it's the salary that's on the first 3 and it's employed on the last one. Okay, there's nothing stopping that from showing up incorrectly. Same with these ones. Okay, so this means dependent variable labels will help you do that. And if you want to change your X variable labels on the ones you still have in the table, you need what are called covariate labels. Covariate is it's a synonym for X variables or independent variables, covariates. Okay, now again, it's going to go in order, so what I'm going to do is just take a look at my table. First one says econ. I just wanted to say economics, and it's a dummy, but my readers will know that because I will have explained that already. Female, that's fine, but I want it to be capitalized. And then the third one, let's see what happens if we just do econ by itself. Good, so you might even do this, right? You might do one variable name, refresh, be like, okay, is it getting to the right one? Yes, economics is on econ, great. Let's keep adding. Female should go to the female variable, capital F. Good, it did. And then finally, that interaction term is economics times female. Cool. Looks good. So I would be good with this. Control A, Control C. Let's get rid of this one. Paste it. This can go right in my paper. Very good looking table. My readers can see my coefficients, my standard errors, observations R squared. The stars will help with statistical significance. So this says in some null hypothesis that the correlation between econ and salary, how different is it for female and male workers? It's not statistically different, so we can't reject the null that there is no difference. However, we can reject the null at a 5% significance level that actually we can reject the null that there's no difference in employment as a result of majoring in economics. It seems that there probably is, with an additional boost for female college graduates. Cool. The last thing you might do is remove these numbers here, although I kind of like them. So like when I'm typing in my paper, I might say, okay, model 1, and the reader will know, okay, this parentheses is this model 1. Model 1 shows correlation between economics, majoring, or having a degree, really. It's not majoring because they all have degrees. It's having a degree in economics and salary. And then later I'll talk about model 3, shows the interaction between yada yada. Okay, so this tells the reader which column I'm referring to, right? And when I say, model 2 includes controls for race and age. Good. Okay. So that's results tables. You could use 2 of them. Suppose you just really get, you're really getting carried away with different data sets, different Y variables, and you just want to, like, maybe I show columns 1 through 3 for salary, and then repeat it again so that I can see the correlation with employed. Right? Maybe I want to actually remove the employed from here, in which case I could do this, take that out of the dependent variable labels. Now we're back here, and then I just want to do the same thing, but with a dependent variable of employed. So let's call this results 2. The dependent variable is employed. And then let's see what's the best way to code this. I'm going to go like this. Ooh. 4, 5, 6, employed, 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 employed. 4, 5, 6. Cool. Now I've got a separate table that's for employed, although because employed is a dummy dependent variable, actually I probably should get 3 digits here. And that might be a good reason to split these tables up, but that's up to you. 3 digits, there we go. Now I can put this in my paper as well and say, well, I also test the relationship between majoring in economics and being employed. All right, and those are regression results tables. That's one thing we're going to need to do with stargazer. The second thing is within your data section of your paper, you need to show summary statistics. The idea here is to give your reader a sense for, well, what is a typical salary, or how many people major in economics, or help us like visualize your data. Okay, because some of us are unfamiliar with the levels or what is a common value for some of your important variables. Okay, now stargazer will also help us do this. I'm just going to use my salary data and not do it for employed, although I could. It would be all the same steps. So if you just do stargazer salary, and in this case, you're not feeding it like the regression results. You're just feeding it a data frame. Let's see what it does. Oh. All right, so I haven't told it HTML yet. Let's do that. Type equals HTML, and then let's output it. Call it summary. All right. Let's see what it does. Okay, so here's what it's going to do. I feed it my data called salary, and what it's going to do is take every single variable in my data, and is going to be how many how many rows have a value here. So if there were missings, I would get a number smaller than that for this variable. What is the mean of the variable? The standard deviation, min and max. Cool. So therefore, when somebody looks at my paper, they can see, well, you know, the average worker makes $95,000, but the standard deviation is $101,000, which says that there's a huge skew. Some poor sucker in the data says they made a salary of $4 last year. That's fine. And on the fortunate side, somebody answered 791,000. So this gives us a feel for the range. But if you paste this table in your paper, you are doing your reader a huge disservice because this is a mess. All right, let's clean it up. First, I would say let's get rid of a lot of these things, especially anything where the mean doesn't make sense, okay? So race, where is it? Race is a categorical variable, but the categories are numbers. They go from 1 to 9. And if you tell me that the average race is 2.3, that's a meaningless number because it's just averaging across categories. It's meaningless. So we don't want that. Let's keep the ones that make sense. So I want to keep salary. Now, I'm going to press enter after this comma because I just want to keep these things organized. Let's keep age. Let's keep female as a variable. And these need to perfectly match what's in the table. This is the variable name. R is very picky. And then let's do econ. All right, that's better. So in your summary stats tables, you can include any variable where it's either a count variable or it's continuous or it's a dummy. Dummies are fine too. Econ's a dummy. And allow it to then take the means, standard deviation, mins, and maxes, but no categoricals. Okay. Next. Maybe I want to trim the digits. Show me only 2. Okay. Now stargazer is kind of smart here. It knows that, well, if this rounds to a 0.00, then you won't get any information here. So it actually leaves econ as a 3 digits, which is good. So we can see this 2.0002 at the end. This means 0.2% of salaried workers have an econ degree. Okay. Good. And of course, the mins and maxes being zeros and ones helps our reader see that this is a dummy, and therefore this is also, 52% of salaried workers are females. And the average worker is 44 years old. All right. Next. These variable names, don't like it. I don't like it. We need to make it look better. So again, this is covariate labels. Then we need to make a list. And this is the last thing I'm going to do because it's just going to put them in order. If I put age as the first one and run it, it's going to apply age to age, and that's great. But if I screw up, it's not going to know. So if I put employed, where it's supposed to say salary here, if I put employed, there's nothing stopping R from saying call that one employed, even though that's not what it is. Okay, so I'm just going to take this bit by bit and make sure that these are getting matched to the right places. Salary, economics, and female. Okay. And therefore, a word of warning here is, and this is also true for your results tables, is if you come back and add more in here and say you want to keep, I don't know, let's see, what is in my data? Let's see all my variables again. Structure, salary. Hours, let's do hours, work hours. If you come in here and keep work hours and run it, there's no telling where these labels are going to end up being applied to. Okay, so it did work out for hours to be at the end. Not sure that that's always true. So you'd want to double check and make sure you're getting a match between your variables and the names here. Okay, so that's why I always do this covariate labels at the end, and then I'm careful that if I ever go back and add more variables, I need to make sure they're getting matched. Okay, but this table can go right in my paper too. In my data section of my paper, which would come before my results, but you know, this is Microsoft Excel, so trying to figure out how to move this table down is like freaking working for NASA. So I'll just paste it here, and there we go. There is my summary statistics table. And this will go in my data section to help my reader see. Maybe I could make that, spread them out a little bit, but help my reader understand the scales that we're talking about in the data. And there it is. That's making tables. I might also put a title on the summary statistics. Let's do that. That's killing me. Title. Summary statistics. Right. Help your reader know what they're looking at. Because some people won't read every single word of your paper. Some of them will skim. They'll look at your tables and jump right to the tables, jump right to the figures, and they'll say, I bet I can figure this out. I don't need to read every word. And maybe they're right. So help them out. So these are summary stats. Okay, that's tables.